The Younger Dryas event offers lessons for humanity in an age of accelerating climate change. Around 12,900 years ago, the Earth experienced a sudden and dramatic climate reversal known as the Younger Dryas event. Just as the planet was warming from the last ice age, temperatures unexpectedly plummeted, returning many regions to near-glacial conditions. This abrupt cold spell, which lasted approximately 1,200 years, transformed ecosystems, altered the course of human history, and left an indelible mark on Earth's geological record. Today, as we face unprecedented climate changes, studying events like the Younger Dryas can provide critical insights into both natural climate variability and potential strategies for adaptation. Investigating the causes of the Younger Dryas event. The precise causes of the Younger Dryas remain a subject of scientific investigation, with two primary theories leading the discourse, the meltwater hypothesis and the extraterrestrial impact theory. Each presents a distinct perspective on how this rapid cooling event could have been triggered. 1. The meltwater hypothesis. One widely accepted theory suggests that the Younger Dryas began with a massive influx of freshwater from melting glaciers in North America. As the Laurentide ice sheet, a vast glacier covering parts of present-day Canada and the northern United States, melted, it released enormous quantities of freshwater into the North Atlantic Ocean. This sudden release likely interfered with the ocean's thermohaline circulation system, a network of ocean currents that redistributes heat globally. The thermohaline circulation depends on the balance of warm and saline waters that move between the equator and the poles. The massive freshwater surge could have disrupted this balance, stalling the Atlantic's ability to transport warm water to northern latitudes, leading to a dramatic regional cooling in Europe, North America, and parts of Asia. This hypothesis is supported by sediment cores and fossil records showing clear changes in ocean salinity and temperature patterns. 2. The extraterrestrial impact theory. An alternative theory posits that an extraterrestrial event, such as a comet or asteroid impact, triggered the Younger Dryas. This hypothesis is based on the discovery of a distinct sediment layer, known as the Younger Dryas boundary layer, which contains unusual concentrations of iridium, platinum, and nanodiamonds, materials often associated with high-energy impacts. Proponents argue that a comet or asteroid could have struck North America or released debris into the atmosphere, blocking sunlight and causing a nuclear winter effect. Although this theory is not as widely accepted as the meltwater hypothesis, it remains plausible due to the presence of these unique materials in specific geologic layers. Some scientists even propose a combination of factors, including impacts and meltwater flows, could have created the rapid cooling observed during the Younger Dryas. Environmental and biological outcomes of the Younger Dryas. The consequences of the Younger Dryas were profound and widespread. Ecosystems that had been adapting to warmer conditions suddenly faced freezing temperatures and shifting climates. Cold-adapted plant species, like the Dryas flower, reappeared in areas that had briefly been covered with forests. Many animal species, particularly large mammals such as mammoths, mastodons, and giant ground sloths, faced extinction during this period. The pollen record provides insight into the drastic shifts in vegetation, with tundra and boreal forests spreading to regions previously characterized by temperate forests. These changes had a cascading effect, as the large herbivores that relied on specific vegetation struggled to survive in altered habitats. In North America, this extinction event coincided with the arrival of early human populations, who may have also contributed to the demise of these animals through hunting pressures. However, the rapid climate shift likely made these species more vulnerable, accelerating the ecological transformations underway. The Younger Dryas and human societies. The abrupt cooling of the Younger Dryas not only reshaped ecosystems but also had significant impacts on early human societies, particularly in the Near East. Archaeological evidence suggests that communities in this region were beginning to experiment with plant cultivation, a precursor to agriculture. However, the return to colder and drier conditions during the Younger Dryas likely made agriculture difficult or even impossible in some areas, forcing early humans to adapt. One of the most affected cultures was the Natufian culture in the Levant, known for its semi-sedentary lifestyle and early plant cultivation. The harsh conditions of the Younger Dryas led to a temporary decline in settlement density and may have driven these communities back to a more nomadic or diversified subsistence strategy. Yet, this period of adversity is also believed to have stimulated agricultural innovation, setting the stage for the eventual rise of farming in more complex societies once the climate stabilized. How the Younger Dryas informs modern climate adaptation. Understanding the Younger Dryas is particularly relevant today, as we face rapid climate shifts driven by human activities. While natural and human-induced climate changes differ in cause, the Younger Dryas provides a valuable case study in understanding the impacts of abrupt climate change and potential adaptation strategies. 1. The importance of resilience and flexibility. The Younger Dryas illustrates how ecosystems and human societies are forced to adapt in the face of rapid change. For early human societies, resilience was critical. Communities that could quickly adapt their subsistence strategies were better equipped to survive. This lesson underscores the importance of fostering resilient systems today, from diversified food production methods to flexible infrastructure planning that can withstand varied climate conditions. 2. Predictive models based on historical data. By analyzing the geological and biological markers from the Younger Dryas, scientists can refine models that predict how ecosystems respond to sudden climate changes. These models are essential in guiding policy decisions for habitat conservation, water resource management, and urban planning under changing climate conditions. The sediment and ice core records from this period offer a unique baseline for examining how temperature shifts affect biodiversity, rainfall patterns, and ocean currents. 3. Proactive conservation and ecosystem management. The ecological impacts of the Younger Dryas demonstrate that abrupt climate events can cause massive biodiversity losses. To avoid similar outcomes, conservation strategies should focus on protecting ecosystems and species that are most vulnerable to temperature and habitat shifts. Proactive conservation measures, including the preservation of migration corridors, reforestation, and wetland restoration, can help buffer ecosystems from the most severe impacts of modern climate change. 4. Adapting agriculture for a variable climate. As the Younger Dryas influenced early agricultural practices, today's climate challenges call for resilient agricultural systems. Strategies such as crop diversification, soil health improvement, and water-efficient farming can help mitigate the effects of extreme weather. Lessons from the adaptation strategies developed by ancient societies can inform approaches that modern agriculture can use to maintain food security amid climate volatility. Lessons for the future. The Younger Dryas serves as a stark reminder of the Earth's capacity for rapid environmental change and the complex interplay of factors that can drive such shifts. By studying this ancient climate event, we gain insights not only into the mechanisms that cause climate change but also into the resilience required to navigate it. Humanity now faces its own era of climate challenges, but with foresight, adaptable strategies, and resilience, societies can prepare for the uncertain climate future that lies ahead.